Solve the differential equation second derivative of y with respect to x minus 3 into first derivative of y with respect to x plus 2 into y, that is equal to e to the power 3x, finding complementary function and particular integral. To solve this inhomogeneous differential equation, we will first find out the complementary function, then we will find out the particular integral, and the solution of this differential equation is the sum of complementary function and particular integral. To find the complementary function, let the solution of the differential equation is y equal to e to the power mx. So first derivative of y with respect to x will be equal to derivative of this exponential function, that is m into e to the power mx. Then second derivative of this function will be equal to taking the derivative of this exponential function, that is equal to m square e to the power mx. So if you put the value of y, first derivative of y and second derivative of y in this equation, then we'll have second derivative is equal to m square e to the power mx minus 3 into first derivative of y with respect to x, that is equal to m into e to the power mx. So minus 3 into m into e to the power mx plus 2 into y, so 2 into e to the power mx, because y is equal to e to the power mx, that is equal to e to the power 3x. So if you take it is homogeneous. So if you take this is homogeneous, then this part will be equal to 0. To find the complementary function, you have to find the auxiliary equation. So making it to 0, if you take common e to the power mx, in the bracket you have m square minus 3m plus 2, that is equal to 0. Because in the inhomogeneous equation you will have e to the power 3x, but if it will be homogeneous, then it will be equal to 0. So since e to the power mx is the solution, that will be not equal to 0. So this will be equal to 0. This part will be equal to 0. So m square minus 3m plus 2, this will be equal to 0. So if you find out the roots of the equation, then you will take 3m is equal to minus 2m minus m, and if you take m common, it will be equal to m minus 2, and if you take minus 1 common, m minus 2, that is equal to 0. So m minus 1 into m minus 2 is equal to 0. So you will have two roots, one is your m1, another m2. m1 is 1 and m2 is 2. Then you can find out the complementary function. So the complementary function will be equal to the constant into e to the power m1x plus another constant into e to the power m2x. So the complementary function will be equal to c1 e to the power m1 is 1, so c1 e to the power x plus c2 e to the power 2x, because m2 is another root 2, so e to the power 2x. So here c1 and c2 are arbitrary constant. So this is the complementary function of the given differential equation. Now we'll find out the particular integral of the given differential function. Now let us find the particular integral of the given inhomogeneous differential equation. The differential equation is this, and if you take derivative as d, then second derivative will be equal to d to the power 2, and first derivative is d, so minus 3d plus 2 into y, that is equal to e to the power 3x. As you have discussed in the previous video, how to find the particular integral. You watch the previous video how to find the particular integral for n number of nth derivative, and this is for the second derivative. So for nth derivative you write fd, and here for second derivative for this term you write fd and into y, that is equal to x. x is equal to e to the power 3x. Then y will be equal to 1 by f d into x. And this is your particular integral. I have discussed about the particular integral in the previous video. So you watch the previous video, then you watch it. So the solution will be equal to solution. You will find the solution if you find out the particular integral, and the particular integral is equal to 1 by f of d into x. And if a is the roots of the equation, then 1 by f of dx will be equal to 1 by f of a into x. And here the roots of the equation we have taken here m, because the d square minus 3d plus 2, this term what you have taken in this case particular integral, this is the equation m square minus 3m plus 2 when you find out the complementary function. That means here we take a equal to m, that is equal to 3, is not it? Because when you find fd, that is equal to fa, here fd is equal to fa, a is the root, and here what is the root? The root is equal to m, or that is equal to 3. Because the solution we have taken y is equal to e to the power mx, and m is the root of the equation, and here m value is equal to 3. So here a equal to m, which is equal to 3. So here d square minus 3d plus 2, this is f of d, or this, that is equal to f of a, and particular integral is 1 by f of a into x, and fa is equal to this quantity, that means d square or a square, that is 3 square minus 3d, so 3 into 3 plus 2, this quantity, that is f of d or f of a, and x is equal to e to the power 3x. You see, x is equal to e to the power 3x. So the particular integral will be equal to e to the power 3x divided by 2. So how you can find out the complete solution? As I have told you, the complete solution is y, that is equal to sum of complementary function plus particular integral. And complementary function we have found out c1 into e to the power x plus c2 into e to the power 2x, and particular integral is e to the power 3x divided by 2. So the complete solution y will be equal to c1 into e to the power x plus c2 into e to the power 2x plus e to the power 3x divided by 2. So in this way you can find out the solution of inhomogeneous equation by means of complementary function and particular integral. Thank you.